Hi everyone, so this is chapter 2 video part 3, and we discussed a little bit about the periodic table in the last video, and I wanted to just ask you a quick question to make sure that you guys are understanding the big picture here. So the question is, which metal has the most metallic character? Now, we learned that most of the periodic table is composed of metals, but just out of logic, which metal do you think has the most metallic character? Another quick question would be, in viewing the periodic table, do chemical properties change more across a period or down a group? This should be really easy for you guys to answer. This slide begins section 2.5, which is called Molecules and Ions. Now, we've talked about what a molecule is, but let's go over it again. A molecule is an aggregate of two or more atoms in a definite arrangement held together by chemical forces. I give you some examples: H2, H2O, NH3, which is ammonia, or CH4, which is methane. What's the difference between a molecule and a diatomic molecule? Well, a diatomic molecule is exactly what the word says, di. That prefix di means two. So it contains only two atoms. A diatomic molecule only contains two atoms. I've given you some examples. H2, N2, so those only have two atoms of nitrogen, so therefore it's considered a diatomic molecule. O2, H2, like I said, HCl, those are two atoms, and that is a molecule. And since it has only two atoms, it's a diatomic molecule, just like carbon monoxide, the last one, CO. Alright, so on the right, I'm showing you a small version of a periodic table. There's 7 elements, and obviously the ones that are in blue are the only elements that exist as diatomic molecules. And as you can see, it's hydrogen, nitrogen, oxygen, fluorine, chlorine, bromine, and iodine. These 7 elements do not exist as monoatomic elements. So you don't find hydrogen, just one atom by itself in nature. Usually you'll find it as a diatomic molecule, a hydrogen next to another hydrogen. A good question to ask yourself is, why do you think that is? Why do you think they exist as diatomic versus monoatomic species? Alright, so if diatomic means containing only two atoms, then a polyatomic molecule is something that contains more than two atoms. So basically everything else. So you have O3, which is ozone, or water, okay, or NH3. And you're saying, wait a minute, water only has hydrogen and oxygen. That only makes it two. But no, you have to remember there's two atoms of hydrogen and one atom of oxygen. So in total, there's 3 atoms. That O3, that ozone, there's 3 atoms of oxygen. That's what the little subscript means, okay? Methane, which is CH4, is a molecule, but is also considered a polyatomic molecule because it's got more than 2 atoms. It's got 1 atom of carbon and how many of hydrogen? 4 of hydrogen. So those are the differences between the different types of molecules. Now that we know what molecules and diatomic molecules and polyatomic molecules are, let's talk about ions. So an ion is an atom or group of atoms that has a net positive or net negative charge. The number of protons in the nucleus of an atom always stays the same during ordinary chemical changes, but the electrons may be lost or gained. Alright, so when you lose or you gain electrons, you get a net positive or a net negative charge. A cation is an ion with a positive charge. Now, this is something that you have to really think about, because if you have a sodium which starts out with 11 protons and 11 electrons. Remember, everything in the periodic table is neutral. If you have 11 protons and 11 electrons, you have no net charge. Now, if you lose an electron, you become more positively charged than you were before, because again, electrons have a negative charge. So if you lose a negative charge, you become more positive. As an example, I show you here sodium. Sodium starts out with 11 and 11. 11 plus, 11 minus. All right, neutral atom. But when you get a sodium atom and it loses one electron, you now have 11 protons and 10 electrons. So now there's more positive charge than there is negative charge, and that's why it's called a cation. A cation are those with positive charges, an ion with a positive charge. The opposite of that would be an anion. That's an ion with a negative charge. As an example, I show chlorine. Chlorine normally comes as 17 protons, 17 electrons. You can look it up in the periodic table. It has a number 17 right above it. If it gains an electron, because remember, in ordinary chemical changes, only losing and gaining electrons, not protons. So if we gain an electron, that means that then you would have 17 protons and one more electron, 18 electrons. That gives it a net negative charge. Those are called anions. You have to become familiar with these because we will talk about these throughout the entire semester. If you put two ions together to make a compound, for example, if you put together an anion like chlorine and a cation like sodium, you make ionic compounds. So that's what ionic compounds are composed of. They're composed of two different ions coming together. And of course, if you're going to come together, you have to be of opposite charges. So cations will react with anions to make an ionic compound. Does anybody know what this is? I've given you a hint, right? So this is table salt. It is ordinary table salt. It's called sodium chloride. You can have two different types of ions. You can have a monoatomic ion and a polyatomic ion. A monoatomic ion is one that contains only one atom. I've given some examples: sodium, chlorine, we've seen those already. Ca, that's calcium. Next is oxygen, aluminum, and nitrogen. I want to point out that you need to start to be familiar with the different elements, at least elements 1 through 54, because I will give you the periodic table in the test, but you will not have the names of the elements. So you need to recognize the symbols. A polyatomic ion contains more than one atom. So that's anything that has more than one. Poly means more than one. Mono means one. So polyatomic ions, some examples are hydroxide, OH, very common, you need to know that one. Cyanide, ammonium ion, and then NO3 minus, that's nitrate ion. We will learn how to come up with those charges very soon. This is figure 2.11 from your book, and it shows us the common monoatomic ions arranged according to their positions in the periodic table. I would become familiar with these ions right here and these ions right here. You will see these again and you will be tested on them in exam 2. A good question to ask yourself is, why is it that all of column 1 all have positive 1 charges, right? Because it just has a plus, so that means it has 1 less electron. What about column 2? Column 2 has 2 plus, so that means that there's 2 less electrons than what it started. Remember that everything on the periodic table begins as a neutral atom, but for you to become an ion, you have to lose or gain negative charges. If I have magnesium, which is Mg, the ion becomes Mg2 plus. How many electrons has it lost? And in the same manner, you can ask yourself the other ions. For example, C4 minus. So that means that it's got 4 more negative charges than what it started with. So how many electrons has it lost or gained? Section 2.6 of your book talks about molecular formulas and the difference between those and empirical formulas. We know what a molecular formula is, we've talked about that before, but that basically shows the exact number of atoms of each element in the smallest unit of a substance. So it's the normal formula that you would see. As you can see, I've shown you some examples on the left. So molecular formula would be like H2O, C6H12O6, which is glucose or sugar, right? Another name for sugar. Ozone, which we've seen before, or N2H4. Now, an empirical formula shows the simplest whole number ratio of the atoms in a substance. So basically, you're taking the least common multiple, I think it's called in math. But for example, H2O, what would be the empirical formula? You basically ask yourself, Can I divide anything into those numbers? H2O, not really, right? Because that's in its simplest form. What about C6H12O6? Well, yeah, if you divide what into each of those numbers, into each of those subscripts, you can get something simpler. What would you divide? 6, I hope you said. So 6 can go into 6 one time, 6 can go into 12 two times, 6 can go into 6 one time for the oxygen. So you end up with something like what you see on the right, which is CH2O. What about O3? Since O3 is by itself, you can do it. So I can divide 3 into 3 and get 1. So the empirical formula of ozone would just be oxygen. What about the last one, N2H4? Well, of course, you can divide 2 into each of those subscripts and get something simpler, NH2. The reason we didn't do it for H2O is because you have to be able to divide it into every atom of the compound. And H2O, you would be able to say, well, I can divide 2 into everybody, but you can't, because you can't divide 2 into 1, right? Because oxygen, there's only one of them. So every number of what you're dividing has to be able to be divided by every component of that formula. This is the last part that I'm going to talk about in this section. The only thing we have left, which I will do a video number 4 for chapter 2, is we're going to talk about ionic compounds a little bit more and start talking about naming compounds and naming the difference between ionic compounds and molecular compounds and naming those different types of compounds. All right, see you later.